Hello everyone, good evening. So here we shall solve some more uh, KCET previous year questions on the chapter Thermodynamics. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos or in any other chapter of chemistry. If you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that if 1 mole of ammonia NH3 and 1 mole of hydrogen chloride are mixed in a closed container to form ammonium chloride gas, which is NH4Cl, then delta H is less than delta U, or what will be the relation in between delta H and delta U that we have to find. So delta H is the change in enthalpy. So as we know that delta H is equals to delta U plus delta Ng into RT. So here we have to find delta Ng, that is the number of moles of the gaseous products minus the number of moles of gaseous reactants. So delta Ng is the change in the number of moles of the gas. So it is the number of moles of gaseous reactants. So only gases we have to use. Number of moles of gaseous products minus the number of moles of the gaseous reactants. Number of moles of gaseous reactants. So that will be equal to, so here 1 mole of gaseous product has been formed. So NH4Cl is ammonium chloride gas, and HCl is also hydrogen chloride gas, and ammonia is also a gas. So here 1 mole is of ammonia reacts with 1 mole of HCl to form 1 mole of NH4Cl. So delta Ng will be 1 minus 2, that is equal to minus 1. So therefore delta H I can say that is equal to delta U minus RT. So therefore it means that the change in enthalpy, that is less than the change in internal energy. So as we know, delta H is change in enthalpy, change in the molar enthalpy, and delta U is the change in molar internal energy, change in internal energy. So here, as you can see that delta H will be slightly less than delta U. So therefore delta H is less than delta U. So option A is the correct answer. Then here it is told 1 mole of which of the following has the highest entropy? Mercury, diamond, liquid, nitrogen, and hydrogen gas. So as we know that entropy of a gas will be the highest. So the en entropy of gas is maximum. Since why? Gases are in the most disordered state. Since uh, in gases the randomness is the highest, randomness is maximum. Since for gases the molecules are always in random motion or in chaotic motion, so entropy of any gas is the highest. As we know that mercury and liquid, nitrogen, these are in the liquid states, and diamond is in the solid state. Diamond is in solid state, so they will not have uh, so they will have l- lesser randomness or lesser entropy than the hydrogen gas. So option D is the correct answer. Then it is told, consider the Born-Haber's cycle for the formation of an ionic compound given below, and identify the compound Z that is formed. So here, as we can see that the metal M, it changes to the gaseous state. Here we have the enthalpy change, and then we have the ionization enthalpy. Then X2 changes to X minus. Now this delta H4 is called as the electron gain enthalpy. So hence M plus, hence we can see that this M plus will react with X minus to form MX. MX is the ionic compound Z which is formed. If I so here so here actually we should add the lattice energy also, since why M plus in the gaseous state in X minus in the gaseous state, that should form since ionic uh, Mx solid. So this change in enthalpy, that should be the lattice energy, lattice enthalpy, that is, which is delta H5. And here there should be some hydration energy also. Hydration energy should be also there. So here option A is the correct answer. Then here it is told that the enthalpy of formation of NH3 is minus 46 kilojoule per mole. The enthalpy change for the reaction this is. So the enthalpy of formation, we can say, so here 1 mole of nitrogen means half mole of N2 plus 3 by 2 moles of hydrogen should react to form NH3, 1 mole of NH3. So here the formation enthalpy, that is equals to minus 46 kilojoule per mole. Now the enthalpy change for this reaction. So if we multiply this by 2 and if we reverse the reaction, then the enthalpy, the sign of the enthalpy change will be reversed. It will be NH3 will give half N2 plus 3 by 2 H2. So here the change in enthalpy, that will be equal to minus the negative of formation enthalpy, that is 46 kilojoule per mole. Now if we multiply by 2 on both sides, then we will have 2 NH3, that will give N2 plus 3 H2. Delta H, so here the enthalpy change, it will be equal to minus of twice of formation enthalpy. So that will be equal to 46 into 2, that is 92, plus 92 kilojoule per mole. So that will be plus 92 kilojoule. So option B is the correct answer. Then here it is told enthalpy of vaporization of benzene is, enthalpy of vaporization of benzene is, so benzene, okay, at its boiling point 80 degrees Celsius, the entropy change in the transition of the vapor to liquid at its boiling point in joule per Kelvin per mole is. So enthalpy of vaporization. So when benzene, which is C6H6, that will change from the liquid state to the gaseous state, that is the vapor state. Then here some heat will be absorbed. The enthalpy of vaporization, that will be equal to 35 point plus 35.3 kilojoule per mole, which is endothermic. Now, and it will happen at the boiling point, at the boiling point where the temperature is 80 degrees Celsius, or I can say 273 plus 80, that is uh, 3. So this much Kelvin, that is equal to 3, then 353 Kelvin. Then here the entropy change in the transition of the vapor to the liquid. When the vapor will change into the liquid, means the gaseous state will change into the liquid state, then what will happen? So here the enthalpy change, I can call it delta H1, that will be equal to negative of the vaporization and enthalpy. It is minus 35.3 kilojoule per mole, enthalpy of vaporization. Then here the entropy, okay, so here the entropy change we have to find, that is delta S, that is equal to Q reversible by T. So it is equal to the change in enthalpy delta H1 by T. So that will be minus of enthalpy of vaporization, that is minus 35.3 kilojoule per mole divided by 353 Kelvin. So we have to write in joule per Kelvin per mole. So 35.3 kilojoules, so that is minus 35300 joule per mole per Kelvin, and then divided by 353. So that will be minus 100. So that is minus 100 joule per mole per Kelvin. So it means option B is the correct answer. Then here it is told for the reversible reaction delta G equals to minus 350 kilojoule delta G naught, and then which of the following statements is true? The entropy change is negative. Okay, here the entropy change. So as we know that delta G naught, that is equal to delta H naught minus T delta S naught. Now since, and we know that if delta G is negative, it means the reaction is spontaneous. The reaction is spontaneous. So here the reaction should be instantaneous. Equilibrium constant is greater than 1, so we have to find that so delta G is negative, it means the forward reaction is spontaneous. Forward reaction is spontaneous, and we also know that delta G naught, that is equals to minus RT ln K, RT ln K, where K is the equilibrium constant. So here delta G naught is negative, so it is minus 35000 joule. It is equals to RT minus 2.303 RT log K. So it means that log K, that is equal to 350000 divided by 2.303 R into T. So R is 8.314 into T. T is equal to 298 Kelvin. So then here we can say that this is approximately, so this will be obviously greater than 1. So it means K will be obviously more than 10. It means the equilibrium constant, since why we can, if I take this as 300 and this is 9 and this is 2, so 300 into 9 to 2700 into to 2, say 5, let's say if you take it as 3 also, so it will be 8100. So 3 is 3,50,000 divided by 8,100, so that will be obviously more than 1. So this value should be obviously more than 1. So K value is more than 10. So the equilibrium constant is greater than 1, obviously. So it means the forward reaction is spontaneous and the equilibrium constant is greater than 1. So option B is the correct answer. Then here it is told, based on the first law of thermodynamics, which one of the following is correct? Based on the first law of thermodynamics. So for any thermodynamic process, we so according to the first law, of thermodynamics, for any thermodynamic process, we have delta U equals to delta Q plus W, or I can say Q plus W. Delta U equals to Q plus W. So now for isochoric process, now so from here we can say also that delta U equals to Q plus W is minus P delta V. So now for isochoric process, so it is actually minus of integral P dV, minus of integral P dV. For isochoric process, the volume remains constant. The volume remains constant, so the work done will be equal to 0. And so we can say that delta U will be equal to Q. And for adiabatic process, we have the adiabatic process Q equals to 0. It means there is no heat exchange in between the system and the surroundings. So it means that delta U equals to W, which is equals to minus integral PdV. And for isothermal process, we can say that delta U will be equal to 0. Since why? Since the temperature should remain constant. So if delta U is 0, it means Q should be equal to minus W, or I can say it will be integral PdV. And for cyclic process, obviously, for cyclic process, the change in internal energy will be 0 only, since here the initial temperature will be equal to the final temperature of the system. So here Q plus W will be equal to 0, or I can say Q will be equal to minus W. So option D is the correct answer. Okay. Then it is told a gas expands from a volume V initial, which is 1 meter cube, to a V to the final volume, which is 2 meter cube, and uh, against an pressure, external pressure of 10 power 5 Newton per meter square. The work done by the gas will be. So the external pressure is 10 power 5 Newton per meter square. So here the pressure is remaining constant. The pressure is constant. So therefore the work done by the gas, that will be equal to, that is equal to P delta V. So we have to find only the magnitude, of the work done by the gas. So it is P delta V, which is P into V final minus V initial. So that will be equal to P, which is 10 power 5 into the final volume, which is 2 meter cube, and initial volume is 1 meter cube. So it is Newton per meter square into meter cube, and which will be equal to joule, which is 10 power 5 joule. Or I can say it is 10 square into 10 power 3 joule means kilojoule. So 10 square kilojoule. So option B is the correct answer. Then it is told that the equilibrium constant of a reaction. The equilibrium constant of a reaction is 0.008 at 298 Kelvin. Then the standard free energy change of the reaction at the same temperature is. So we have to find the standard Gibbs free energy change, that is delta G naught of the reaction at the same temperature. So that will be equal to minus RT ln K, as you know, where K is the equilibrium constant, which we have to find out. We can also write this as minus 2.303 RT log K. So when there is no base for log, this means the base is 10. And for ln, it means log base E. The base is E here. So therefore, we can say that log K, that will be equal to minus delta G naught divided by 2.303 into R into T. Now the T is 298 Kelvin. So minus delta G naught. So here the equilibrium constant has been already told we have to find delta G naught. So delta G naught, that is minus 2.303. RTR is um, joule, it is 8.314 into T is 298 Kelvin into log 0.008. So therefore delta G naught, that will be equal to minus 2.303 into 8.314 into 298 into log 0.008. I can say it is log 8 into 10 power minus 3. So it means it is uh, log 10 power minus 3, which is minus 3 plus log 8. So that will be equal to minus 2.303 into 8.314 into 298 into this is minus 3 plus log 8. Log 8 means 3 log 2. 3 log 2. Now log 2, as we know, log 2 is approximately 0.3. So 0.3 into 3, that is 0.9. So 3 minus 3 plus 0.9, so that is minus 2.1. This will be 2.303 into 8.314 into 2.1 into 298. This much joule. The answer are given in kilojoule. So therefore, the value of delta G naught, which is the standard Gibbs free energy change, that is equal to so 2.303 into 8.314 into 2.1 into 0.298 kilojoule. So this will come. So if we solve it, we will get approximately, so 3, it is approximately 0.3. So we can say it is approximately 2.3 into 8.3 into 2 into this is 0.3, suppose, approximately. So this is 0.6, 0.6 into this is suppose 8, 8 into this is suppose 2.5, suppose 2.5, so into 8, so 5 by 2, 2.5 means 5 by 2, 2 4 is 8, 4 5 is 20, so 2 3 is 12. So approximately 12 kilojoule should come. Approximately 12 kilojoule. So that is 11.96. So it is approximately option A. Approximately it is option A. It is plus 12 kilojoule. Then here it is told which of the following statements is true. Which of the following statements is true? The total entropy of the universe remains constant, which is false. So as we know, according to the second law of thermodynamics, according to the second law of thermodynamics, we have the entropy of the universe is increasing, or I can say the entropy of any isolated system. The entropy of any isolated system always increases. So an ideal isolated system, we can call it as the whole universe. So it means the entropy of the universe always increases. The total entropy of the universe is continuously okay, the total entropy of the universe is continuously increasing. The entropy of the universe continuously is increasing, but the total energy of the universe can't change. So the total energy of the universe always remains constant. Since why in an isolated system, since we can say that a universe is an isolated system only, and in an isolated system, there is no exchange of energy from the system to the surroundings. So there is no energy exchange in between the system and the surroundings. So the the total energy of an isolated system always remains constant. The total energy of any isolated system, for example, the universe, that always remains constant since there is no energy exchange. In in case of an isolated system, there is no exchange of heat or energy in between the system and the surroundings. So option D is the correct answer. Then it is told the process is spontaneous at the given temperature if. So for a spontaneous process, so we know that for a process to be spontaneous, for a process to becomes to be spontaneous, we should have we should have uh, delta G equals to delta H minus T delta S. So we know that the change in Gibbs energy should be negative. The change in Gibbs energy should be negative, then only the process will be spontaneous. Now delta G, as we know, change in Gibbs energy, that is equal to delta H change in enthalpy minus T delta S, where T is the absolute temperature and delta S is the change in entropy of the system. So if that is negative, then only we can say the process is spontaneous. Process is spontaneous. So now in the case in the option A, as it is told, if delta H is positive and delta S is negative. So if delta S is negative, then minus T delta S will be positive. So it means delta G, that is delta H minus T delta S, will become positive only. So it means the process will not be spontaneous. It's not spontaneous. And in option B, it is told if delta H is negative, and delta S is positive. So if delta S is positive, then it means that minus T delta S will be negative. So it means here delta G will be negative. So it means here the process will be spontaneous. And in case of option C, it is told if delta H is positive and delta S is also positive, it means then minus T delta S is negative. But here, but uh, if delta H is more than uh, mod of T delta S, then delta G will be positive only. So hence here also we can't say if the process is spontaneous or not. If if the magnitude of T delta S is higher than delta H, then only delta G will come negative and then only it will become spontaneous. Else if the value of delta H is more than the magnitude of T delta S, then the process will be not spontaneous since here delta G will be positive. And in the part D, it is told that in part D it is told that if delta H is positive, delta H is positive, and delta S is equal to 0. Delta S is equal to 0. So here T delta S also will be equal to 0 only. So it means here also delta G is positive. So the process will be non-spontaneous. So it means only in the case of option D only we can say that for any at any temperature the process will be spontaneous. Option B is the correct answer. Then it is told the value of entropy of solar system is. So the value of entropy of the solar system. So we can assume that the entire solar system is approximately an isolated system. Solar system, we can assume that it is an isolated system only. So according to the second law of thermodynamics, according to the second law of thermodynamics, we know that the entropy of any isolated system always increases. Entropy of any isolated system, entropy of any isolated system always increases. So it means the entropy of the solar system should also increase. The entropy should increase. So the value of entropy is always increasing. So option A is the correct answer. Then here it is told for the thermochemical equation. The thermochemical equation, it means where we have a, a balanced chemical equation, where we have a balanced chemical equation of the reaction and with its enthalpy change, with the value of its enthalpy change. That is called a thermochemical equation. So um, here the change in enthalpy when 2H2 gas reacts with oxygen, 1 mole of oxygen gas, then it gives 2 moles of H2O liquid. So here the enthalpy change, that is equals to minus 571.6 kilojoule. Now here the heat of decomposition of water is. So we have to find the heat of decomposition of water. It means that 1 mole of H2O should form 1 mole of H2 plus half mole of O2 in the gaseous form. So here we will have the heat of decomposition. So the heat which will be absorbed, let's say we call it delta H1, that will be equal to obviously here if we reverse this reaction, then it will be the enthalpy will be minus delta H. And since here 1 mole of H2O has been used, so it will be half of this. So it will be minus half of minus 571.6 kilojoule. So this delta H1 will be the required heat of decomposition of water. Heat of decomposition of water. So that will be equal to half of 571.6 kilojoule. So that will be equal to 2 twos of 4, then 2 8s are 16, 2 5s are 10, 2 8s are 16. This much kilojoule. So it is plus 285.8 kilojoule. So option D is the correct answer. Then here it is told the ratio of heats liberated. The ratio of heats liberated at 298 Kelvin from the combustion of 1 kg of coke. Ratio of heats liberated at 298 Kelvin from the combustion of 1 kg of coke. So C plus O2 gives CO2. So here some heat will be evolved. Ratio of heat is evolved by the combustion of 1 kg of coke. 1 kg is used, and by burning water gas obtained from 1 kg of coke. Now water gas, it means CO plus H2. This is called water gas. By burning water gas is obtained from one from hmm, yeah, is okay. So here also it will react with O2 to give CO2 plus H2O. here some heat will be evolved. So we have to find these ratio of heats that is uh, liberated. So here let's call this as delta H1. This is delta H2. You have to find out and assume that this coke is 100% carbon. It means that it is 100% pure. It is pure carbon. Okay. And then enthalpies of combustion of CO2, but here it should be given enthalpy of combustion of carbon. Then CO and H2 are 393.5 kilojoule, 285 kilojoule, and 285 kilojoule respectively at all respectively at 298 Kelvin. So here the reaction, it is told it is happening at 298 Kelvin only. So this carbon monoxide plus hydrogen gas, it is called as water gas. So now therefore the heat that is liberated, delta H1, that we can say that is equal to the enthalpy of combustion. So it is same as the enthalpy of combustion. Okay. So here 1 kg is used. So it is equal to the number of moles times the molar enthalpy of combustion. So here the values which they gave, the enthalpies of combustion, these all are the molar enthalpies of combustion. Molar enthalpies means for 1 mole. So here this change in enthalpy, that will be equal to the number of moles of coke that is used times the molar enthalpy of combustion of carbon. So here it is given the molar enthalpy of combustion of carbon, that is for carbon, that is equal to 393.5 kilojoule. So this will be equal to the number of moles is the given mass, that is 1000 gram, divided by molar mass, that is 12 gram, times the 393.5 kilojoule. So it is actually kilojoule per mole they should give, the molar enthalpy of combustion of carbon. So this will be equal to 2, so okay, 4 3s are 12, 425 is 100. So this will be approximately, so this is equal to 250 by 3 into 393.5 kilojoule. And now, so here we actually have to find the ratio of heats that is liberated from the combustion of 1 kg of coke, and by burning and by burning 1 kg of, yeah, by burning the water gas which is obtained from 1 kg of coke. Obtained from 1 kg of coke. Here should be given 1 kg of coke. Okay. So in the next reaction, what is happening here, from carbon coke, from the coke water gas is obtained first. Here this water gas is obtained from coke, from 1 kg of coke. So it means from 1 kg of coke, that is from 1 kg of carbon, CO plus H2 is obtained. So it means that the number of moles of carbon, that should be same as the number of moles of the water gas which is obtained. So here here also. So therefore I can say this delta H2, that is the enthalpy change for this reaction, for this combustion reaction of the water gas. So here we can also write that is equal to the number of moles of the water gas times the molar combustion enthalpy of water gas. Now the molar enthalpy of combustion of water gas, that will be equal to the molar enthalpy of combustion of CO and plus molar enthalpy of combustion of H2. So it is, which will be 285 plus 285. So it will be the number of moles of water gas times 285 kilojoule, 285 kilojoule plus 285 kilojoule. Now the number of moles of water gas, that is same as the number of moles of carbon only, which is obtained from coke. So that is also 1000 by 12, which is equal to 250 by 3 moles. So here also we can say this will be equal to 250 by 3 into 285 plus 285, which is 285 into 2 kilojoule. So now we have to find the ratio of delta H1 and delta H2, the ratio of heats that is liberated from the combustion of coke and by burning water gas, which is obtained from 1 kg of coke. So therefore we have to find the ratio of delta H1 is to delta H2. So that will be equal to 250 by 3 into, this is 393.5 kilojoule is to, that is 250 by 3 into 258 into 2 kilojoule. So this will be equal to 250 by 3, 250 by 3 will cancel out, and then kilojoule and kilojoule also will cancel out. Then we will get 393.5 is to 2 is 16, 5 to the 10, 1, 0, 4, 5, 516. Okay. 393.5 is to 516. Sorry, this is 285. This is not 258, this is 285. It's 285. So 2 5 is the 10, 2 8 is 16, 17, 2 to the 4, 570. Okay. 393.5 is to 570. So this will be approximately equal to, this is equal to 0.69 is to 1. So option B is the correct answer. Then here it is told the conversion of oxygen into ozone is non-spontaneous at conversion of oxygen into ozone. So oxygen will form ozone. It's 3 moles of O2 will form 2 moles of ozone. So this, the conversion of this is non-spontaneous at. So here 3 moles of O2 gas will form 2 moles of ozone gas. Here delta H, the change in enthalpy, is positive here. And the change in entropy, is negative. So therefore delta G, that is equal to delta H minus D delta S. So why delta H is positive? Since this reaction, the forward reaction is endothermic. And here the randomness decreases, since here the number of moles of the gas decreases here. The number of moles of the gas that decreases. So it means the randomness decreases. The randomness or the disorderness decreases. So randomness decreases, it means the entropy also decreases. So entropy decreases, it means the final entropy is less than the initial entropy. So change in entropy, that is final entropy minus initial entropy, that will be negative. So here delta G equals to delta H minus T delta S. So delta H is positive and delta S is negative. So it will be positive minus of negative. So it will be a, it will come a positive value only, it will come. So therefore the Gibbs free energy, the change in Gibbs free energy is positive. So therefore, so delta G is positive. So the conversion is the conversion of oxygen to ozone. Conversion of oxygen to ozone is non-spontaneous at all temperatures. Is non-spontaneous at all temperatures. So option A is the correct answer. Then here it is told in the reaction S plus 3 by 2 O2 gives SO3 plus 2x kilojoule and SO2 plus half O2 that gives SO3 plus y kilojoule. Then the heat of formation of SO2. The heat of formation of SO2, so it means that the 1 mole of sulfur should react with 1 mole of O2 to give SO2. So then here we will have the heat of formation, that is the delta H, the heat of formation of SO2, which has to be found. Let's say that is equal to Z. Now, as you can see that if you reverse this reaction, then we will have SO3 gives SO2 plus half O2, and here the change in enthalpy will be minus Y kilojoule. So if we add these two, the equation 1 and the equation 2, so then SO3 will get cancelled, and here 3 by 2 O2 minus half O2, so it is O2 only, so it will be S plus O2 will give SO2. So here, therefore Z, I can say Z will be equal to 2x minus Y kilojoule. 2x minus Y kilojoule. Now here the enthalpy of formation, therefore, will be 2x minus Y kilojoule. So it means option D is the correct answer. Then it is told that if the bond energies of hydrogen HH, Br, and HBr are 433, 192, and 364 kilojoule per mole respectively, then delta H naught for the reaction is, here delta H naught is the standard enthalpy change for the reaction is. Okay. So here we know that the change in enthalpy of the reaction enthalpy, that is equal to the sum of the bond enthalpies the sum of the bond enthalpies, sum of the bond enthalpies of reactants minus the sum of the bond enthalpies of the products. So here sum of the bond enthalpies of HBr. So here 2 moles of HBr are found. So it will be 2 into the bond enthalpy of HBr minus the bond enthalpy of HH. Okay, or I can say the bond enthalpy of H2 plus the bond enthalpy of Br2. So this will be equal to 2 times the bond enthalpy of HBr, that is 364 kilojoule per mole minus, that is bond enthalpy of H2, that is 433, plus bond enthalpy of Br2, that is 192. So this much kilojoule will come. So this will be 2 for the 8, 728 minus 5, 12, 5, 6, 625 kilojoule. So that will be equal to, sorry, so this will be the bond enthalpies of reactants. So this will come first. So this will come first. So here we should write, there is something wrong here, bond enthalpies of reactants. So that will be the bond enthalpies of H2 plus the bond enthalpy of Br2. So that minus twice of the bond enthalpy of HBr. So that will be equal to, this will be 433 plus 192 minus 2 into 364. So that will be equal to 625 minus 728. So that will be equal to minus 103 kilojoule. So it means option D is the correct answer. Then here it is told that the correct statement regarding entropy is at absolute zero temperature. So as we know, so according to the third law, of thermodynamics, the rule is that, so the law is that the absolute en entropy, of a perfectly crystalline solid, of a perfectly crystalline solid at absolute zero, temperature is equal to zero, only. So it means the absolute entropy of a crystalline solid at 0 Kelvin, that will be equal to zero only. So at 0 degrees Celsius, the entropy of okay. So it is not 0 degree Celsius, it is 0 Kelvin we should use. At absolute, since absolute zero of temperature, it means 0 Kelvin. So at absolute zero temperature, entropy of a perfectly crystalline solid is zero, which is called the third law of thermodynamics. So option A is the correct answer. Then here it is told a reaction has both delta S, delta H and delta S negative, the rate of the reaction. Okay, so here so here delta H is negative. It means that the reaction is exothermic. It means it releases heat. Is exothermic. And delta S is negative. Also, it means the entropy decreases. Now here delta G, that is equal to delta H minus d delta S, as we know. Now delta S is negative and delta S is also negative. So now if delta H is more than, if the magnitude of delta H is more than magnitude of d delta S, then only delta G will be negative. And then only the reaction will be spontaneous. Now, and since the reaction is exothermic, so the rate of the reaction will increase. The rate of the reaction increases with decrease in temperature. Decrease in temperature. And if the reaction was endothermic, then the rate of the reaction would have increased with increase in temperature. So it means that option C is the correct answer. It increases with decrease in temperature. Since why, if the temperature decreases, if temperature decreases, then only the magnitude of T delta S will be lesser than the magnitude of delta H. And then only the delta G will become more negative. And if delta G is more negative, then the rate of the forward reaction will be more faster. It means the reaction will become more faster if the delta G is more negative. Now, the reaction in which delta H is greater than delta U is that we have to find out. Now, as we know, delta H, that is equal to delta U minus or plus delta Ng into RT. Delta U plus delta Ng into RT, where delta Ng is equal to, where delta Ng equals to the number of moles of gaseous products minus the number of moles of gaseous reactants. The number of moles of gaseous products minus the number of moles of gaseous reactants. Gaseous reactants. So, number of moles of gaseous products. So, in case of part A, as you know, here 2NO is formed. So, delta Ng, that will be equal to 2 minus 2, that is equal to 0. So, here delta H will be equal to delta U. And in case of option B here, delta Ng, that will be equal to, so here simply it means that if delta Ng is greater than 0, then only delta H will be more than delta U. Delta U. Okay. So the number of moles of gaseous products should be higher than the number of moles of gaseous reactants. So in option B, CaCO3 solid is it forms CO solid and CO2 gas. So here delta Ng will be 1 minus 0, that is 1. So here delta H is more than delta U. Obviously, since here delta H is equal to delta U plus RT, since here delta Ng is equal to 1. And in option C, here delta Ng, that will be equal to number of moles of gaseous products, that is 2 minus 4, that is equal to minus 2. So delta Ng is less than, here delta H is less than delta U, since here delta H is equal to delta U minus 2 RT. And in option D, here delta Ng, that will be equal to, that is here liquid is formed, so it will be 1 minus 2 plus 1, that is 3. So here also minus 2. So here also delta H is less than delta U, since delta H equal to delta U minus 2 RT. So here only in case of option B, the change in enthalpy is more than change in internal energy. So option B is the correct answer. Then it is told, when the same quantity of heat is absorbed by a system at two different temperatures. When same quantity of heat is absorbed by a system at two different temperatures, T1 and T2. So here T1 is more than suppose T2. So here the system is at a temperature T2 and here it is at T1, and same quantity of heat is absorbed. Same quantity Q heat is absorbed. Then the change in entropies are, here it is delta S1, so that will be equal to Q by T1, and here also the change in entropy delta S2, that will be equal to Q by T2. So then we have to compare in between delta S1 and delta S2. So now since T1 is more than T2, so I can say that 1 by T1 will be obviously less than 1 by T2. So it means Q by T1 will be obviously less than Q by T2, since Q is the same amount of heat that is absorbed by the system. So, and since heat is absorbed, so here Q is positive also. Since here heat is absorbed here. So therefore, delta S1 is less than delta S2. Delta S1 is less than delta S2, obviously. And here, since, and here, yeah, yeah. And T1 is more than T2. It also means here the entropy in the first case is higher than the, means the initial entropy in the first case will be higher than in the case 2. So it means that option D is the correct answer. Then it is told the bond enthalpies of A2, B2 and AB are in the ratios 2 is to 1 is to 2. If bond enthalpy of formation of AB is minus 100 kilojoule per mole, the bond enthalpy of B2 is. Now A2 plus B2, A2 plus B2 half, that will form AB. So in this reaction, the bond enthalpy of formation of AB, I can say. So here the enthalpy of formation of AB, that is equal to minus 100 kilojoule per mole. So here the bond enthalpy of B2 we have to find. So now here the reaction enthalpy. Now therefore the bond enthalpy, the enthalpy of formation of AB has been given. Now let's say now the bond enthalpy of AB, the bond enthalpy, can write it like this, the bond enthalpy of AB, that will be, let's say that is equal to 2x kilojoule per mole. Then the bond enthalpy of B2, that will be equal to x kilojoule per mole. And the bond enthalpy of A2, that will be again 2x kilojoule per mole. Since why the ratio has been given 2 is to 1 is to 2. Now therefore, as we know that any reaction enthalpy, that is equal to the bond enthalpies, the sum of bond enthalpies of reactants, minus the sum of bond enthalpies of the products. So here the reaction enthalpy is same as the formation enthalpy of AB. So therefore I can say that this is minus 100 kilojoule, that is equal to sum of bond enthalpies of reactants, that is half of the bond enthalpy of B2 plus half of the bond enthalpy of A2 minus the bond enthalpy of AB. So therefore we can say that minus 100, that is equal to half x by 2, that is equal to x by 2 plus this is 2x by 2 minus this is 2x. That will be equal to, so it will be x plus x by 2 minus 2x, that is equal to minus 100. So we have to find the bond enthalpy of B2. It means x has been asked. So therefore we can say this will be 2x, x minus 2x is minus x, and minus x plus x by 2, that is minus x by 2, minus x by 2 is minus 100, so x will be equal to 200. So therefore the bond enthalpy of B2, that is equal to x, that is equal to that will be equal to plus 200 kilojoule per mole. So option C is the correct answer. Option C is the correct answer. Then here it is told that the work done when 2 moles of an ideal gas expands, 2 moles of an ideal gas expands reversibly and isothermally. So here it is a reversible isothermal expansion. There is a reversible isothermal expansion of 2 moles of an ideal gas. 2 moles of an ideal gas. And so it expands from a volume of 1 liter to a volume of 10 liters at 300 Kelvin. At 300 Kelvin, and here the value of R is equal to 0.0083 kilojoule per Kelvin per mole. Kilojoule per Kelvin per mole. So therefore, you have to find the work done. So work done in isothermal reversible process, so that we know that is equal to minus integral PdV from V initial to V final, or we can see it is equal to minus E equals to nRT by V. So it is nRT by V into dV from V initial to V final. So that will be equal to minus nRT ln V final by V initial. Or I can say it is nRT ln V initial by V final. Or I can say it is 2.303 nRT log V initial by V final. So it will be negative work done only, but we have to take the mod of that. Okay, so therefore it will be 2.303 into n, the number of moles is 2, and R is 0.0083 into T is at 300 Kelvin. At 300 Kelvin, so T is 300, and log V initial by V final, so it is 1 by 10. So log 10 I can use, that is 1. Log 1 by 10 I can write minus of log 10. Log 1 by 10 I can write it minus of log 10, that is minus 1. So we have to take its mod only, so we can write it simply plus 1. So therefore the magnitude of the work done that we have to find, so that is 2.303 into 300 into 0.0083 and into 2 is also there. Okay. ORT. So that will be equal to 2.303 into 2 into 0.83 into 3. So this is 2.3 and 6 into 2.3 into 0.83. So that is 6 3 is 18, 6 2 is 12, 13.8 into 0.83. So we can say this is approximately slightly less than 13.8, that is. So it is 11.5 kilojoule. Slightly less than, okay, it is 11.5 kilojoule. Here, since the R is given in kilojoule per Kelvin per mole, so it will come in kilojoule. The answer will come in kilojoule. Okay. So option C is the correct answer. Then here it is told the temperature of 25 degrees Celsius in Fahrenheit and Kelvin scale are respectively. So as we know that um, the rule is C by 100, that is equals to F minus 32 by 180, and that is equals to K minus 273 by 100. So therefore 25 degrees Celsius, that is same as in Kelvin scale it will be 25 plus 273 Kelvin, so that is 298 Kelvin. 273.15 I can tell. So it will be 273.15 if I add. So it is 298.15 Kelvin. 298.15 Kelvin. And in the Fahrenheit scale, it will be F minus 32 by 180. That is equals to C, that is 25 by 100. So that is 1 by 4. So that is F minus 32. That is equal to 180 by 4. So that is 4 for the 16, 4 5 is the 20. So that is F minus F equals to 32 plus 45. So that will be equal to 77 Kelvin. No, 77 degree Fahrenheit. So 77, so 25 degrees Celsius is same as 77 degree Fahrenheit, and in Kelvin scale it is 298.15 Kelvin. So option C is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Thermodynamics. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also please install our Sapience education application, uh, where we shall upload some important questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.